Right. Okay. Good morning, everybody. Welcome back to Comp 2452. Yeah, I asked before class started, and I think it's not just me. This room is quite cold. I've sent an email to the people that manage this building to ask them to increase the temperature a little bit. But they're not going to do it right now. I don't know when they're going to come and do it, but hopefully before next class next week. I hope you're all doing okay. Today, what I want to spend some time doing is to take some time to look at the expectations and overview for your implementation of phase 2. There's a couple of things I want to spend some time talking about in terms of the implementation of phase 2. So one thing that we haven't really considered as a result of adding the database to our implementation is that we haven't run the tests since we've added the database to our implementation. And there might be a bit of a problem with that. And so let's take some time to look at what the state of things are right now and how we can address the issues that are coming up with that. I want to take the time to talk about a new concept that's not going to change the design of your application. So it's not going to change the domain model that you've got, but it's going to change how you might implement parts of what you're working on. And then what I want to do is spend a little bit of time introducing a new topic to you. So introducing this idea of human-computer interaction. So by the end of today's lecture, what I want you to be able to do is I want you to be able to know a little bit more about the implementation expectations that I've got for your phase 2. Continuing, I want you to be able to use a testing framework to automate running test suites. So like I said, I want to revisit something specifically in the context of using databases for testing stuff. And then finally, I want you to be able to, and now I'm filling in the rest of this learning outcome. So for the first 6 or 7 weeks of this course, this has been implement a simple graphical interfaces using a modern API. So this is really us focusing on like using HTML and JavaScript to build up this application that uses the MVC architecture. But now I'm going to amend to this. I want you to be able to assess graphical interfaces using heuristics that are informed by standard design principles. And an example of this is something that's called feedback. This is what we're going to be spending time looking at like closer to the end of today's lecture and then going on into next week's lecture. So spending some time doing assessment of user interfaces, looking at them from the perspective of human-computer interaction. So let's start by taking a look at the rubrics and expectations for our phase 2 implementations. I put these up on the course webpage yesterday. I did forget to put a news item up, so I'm going to try to make sure I remember to do that after class today, just so everybody's aware of it. But I wanted to take some time to step through these, the kind of additional expectations that I've got and the rubrics themselves. After this, like I said, we're going to do a little bit of like backfill of stuff, and then I'll give you an opportunity to ask questions about the project and about the course. So the overview for this is that we're still assessing you on learning outcomes, but now they're going to be learning outcomes that are purely from Comp 2452. So for phase 2, I'm still expecting you to do testing. This is still going to be a core part of what I'm expecting you to produce as part of your assessment. Still continuing to expect you to be able to do things like implement simple graphical interfaces using a modern API. So you still got to use web tools to accomplish this. I'm still looking for you to do the application of the MVC architecture. But now there's new stuff here that's related to the databases stuff. So create, populate, and query. This was something that you started to do for your design of phase 2, but now I'm going to actually expect you to have these queries actually do something in your application. I want you to start having some stuff related to interaction with the database in your code. I want you to be able to prevent SQL injection attacks on your own code base, and I want you to be able to securely represent and store credentials for authentication purposes. In terms of what I'm expecting you to submit, I've kind of just left this like references to previous submissions. The expectation here for like using version control and the structure of your code that I'm expecting you to submit, this is the same as what you would have done for phase 1. So there's nothing really new here that I want to change. So I kind of just omitted that stuff, but I gave you references to previous parts of this. There are 2 different streams of projects, but across those 2 streams of projects, there are going to be some consistent expectations that I want to see in your implementations for phase 2. The first is that I want your implementation to, in some way, have this REPL that's provided by PG Lite on the page in an obvious way so that the grading staff are able to actually interact with your database. So for one project stream, specifically that point of sale, there's something that I'm asking you to do where there's no UI that I'm asking you to make for it. I want all cashiers to have receipts. There's no way for the grader to check that other than to interrogate your database. So like actually ask questions from the database that you've got. In terms of assessing the functionality that you've implemented for database related stuff, they may be able to give you partial credit if they can see that, yeah, you've got rows that are being inserted into the database here, even if it's not showing up on the page as expected. So I want you to have this in some obvious way, this REPL in some obvious way on the page itself. It doesn't have to be exactly the same as what I've done in the sample projects, but I very much welcome you to just copy and paste that code. So just from my index.html directly into your index.html would be totally fine for this. If you want to hide it in some way, that's fine, but please make it very clear to the grader how to actually get access to that. They need to be able to open this up so that they can adequately assess your work, and making it easier for them makes graders happy, and happy graders are generous graders typically. So I want to make sure that they have a very obvious way to get that open. Please don't put this on a separate page. When we initially set this up, we had this on REPL.html and then we had index.html. But as I mentioned in class, there are consistency issues between having 2 tabs open that are connected to the same internal database. So please make sure that this is actually on the main page of your application. Both project streams have some expectation of user accounts. So registration of a user account, creating a user account, creating a gamer profile, creating a cashier account, and then signing into those accounts. This is something that you should store in your database. So this is an important part of the representing credentials for authentication securely. Your application should have some concept of a current user. Like once I do the sign-in operation, there should be somebody that's signed in that I'm actually doing stuff with. But you don't really need to worry about having an option to sign out. So refreshing the page ought to be effectively the sign out operation. And you also don't need to represent any concept of the currently logged in user in your database. Refreshing the page should just cause me to get the login prompt again, immediately asking for that login prompt. So that means that in your controller classes, for example, or in your domain model, for example, you might have this is the currently logged in user as a class property, but when I refresh the page, it just becomes undefined or null again. We don't have to save this to any kind of table structure. You also very explicitly do not have to have a logout operation. You're not going to lose points if you do have a logout operation, so a button that would cause the currently logged in user to become null or undefined, but you're not required to have that. We're going to hit the refresh button and just expect to see a sign-in page show up again. This is different than what the user is currently doing in your app. And so for the point of sale system, for example, if I'm adding items to my cart, when I refresh the page and then sign back in again, I'd expect those items to still be in my cart. But I don't expect my user account to be logged in when I refresh the page here. So those are distinct operations. Your application should be changing such that you no longer have any hard-coded strings or values that represent the concept of like inventory in your application. I'm going to describe this in a little bit more detail in a couple of minutes, but The idea here is that you should be taking these hard-coded values and moving those into the database. This is the right place to store the concept of inventory in your system as opposed to in your domain model classes. We go all the way back to Comp 2450. At least at the beginning of this course, we're going to be able to say it's fine to have these hard-coded English language strings in your domain model classes. But if we go back to Comp 2450, having hard-coded English language strings in our domain model objects was kind of like, this was not the single responsibility principle. This is giving some responsibility of presentation to our domain model, and we really don't want that. I'm going to describe this in more detail, but you shouldn't have these hard-coded English language strings or values in your application anymore, but you're going to have some internal concept of these things in your database. And you're going to have some internal concept of being able to load all inventory from your database. This doesn't require changing your domain model design. You should still have the concept of products and upgrades and buildings. This is all still part of your domain model, but you really explicitly should not have any concept in your domain model of all things in the database. This is just going to be data that's in your database. This is just going to be a new table that's in your database that corresponds to existing classes in your database. Again, I'll describe this visually in a couple of minutes. The last part here is the other thing we're going to talk about today. You should be able to run your tests, and you should be able to run them repeatedly. So if I run npx vtest once and I run it again, your test should pass both times. If I were to run it n times, your test should pass n times, even with a database in the background. There's a couple of options. I'm going to demonstrate a way to accomplish this using something called environment variables today in class, but you're also welcome to use strategies that you've seen in Comp 2450, like building up your own interfaces for representing operations on your database and then putting those in between your actual domain model classes and the real implementation of an actual database. I also really welcome you to do this option 3 here, and this is using vtest's mock framework. I'm not going to talk about this in class at all, other than what we're talking about right now, because this is a concept that will show up in Comp 3350, that's Software Engineering 1. But really, generally, the idea here is this gives you the ability to effectively replace classes, and it gives you the ability to replace functions so that the thing that uses those functions doesn't need to know that you've replaced them. This is a form of dependency injection, but it adds some extra stuff. And this is me being really, really pedantic about this. This is outside the scope of this course, so don't worry about it. But this gives us the ability to do things like spy on methods. That means that we can have assertions that are not just, did I get the correct output, but I can have assertions that say things like, did you invoke this method 5 times as part of your execution? That's outside the scope of this course. This is something you'll think about in Comp 3350, but be aware of the terminology, I guess, for now. This is something you can expect to see later. If you choose to do this, I kind of got to say you're on your own. We're not going to talk about this in class, but I welcome you to take a look at it and see if you want to try and integrate it. But just like with LazyVim and NeoVim, like, don't let this get in the way of your success. I welcome you to try it, but if it's just like not working for you, just drop it and move on to using the strategy that I'm describing to you in class. All right, so for the rubrics for the assessment of your projects, some of these are going to be the same, although I'm kind of pulling things out of each of these. So for the application of a software architecture to an application, so this is MVC, we're looking to assess you really just on MVC and code quality here. So we're not going to assess you anymore on design by contract. I strongly believe that you should continue to do design by contract appropriately, but that's not explicitly part of the assessment for phase 2 implementation. The structure of this is pretty much the same as what we've seen before, other than not having the design by contract stuff. So I'm going to skip past this. For implementing a simple graphical interface, and this is kind of related to the features that you're implementing that you've designed. I've lowered the demonstrates mastery part here to be you don't necessarily have to have implemented all the features to get to the mastery point, but I explicitly require you to have implemented the login part. So having the accounts must be something that you've implemented to get to mastery for this. For testing, one thing I want to note here is that for the demonstrates mastery at level 2, I've brought down the greater than 70%. I actually, in my assessment of your phase 1 submissions, I don't think I've seen anybody that has less than 90% coverage. So I think that's reasonable for me to do here to lower this down to this. The difference between satisfactory and good here is that we can run the tests once, but they fail on subsequent runs. So something is causing your database to have state that's maintained, and secondary runs of this are going to fail. So if the first run runs correctly, but then the next ones start to fail because of data being in the database, this is where you wind up. The top level one here is I can run npx vtest several times, and it will just succeed every time I run through that. The new things to us for this are going to be these database interactions. So for the first part here, creating and populating and then using a programming language to interact with the database, the things that I'm really looking for here are when I actually start your app up, are there tables in your database now? So I'm expecting to be able to see tables in your database after I start your app up. And I'm also potentially expecting to see some data in your database in the form of this idea of inventory. Again, we'll talk about that in a moment. The other thing I'm expecting to see here is that effectively, anytime you're making changes to instances of your domain model, so adding things to the cart, clicking on the thing that you're clicking on, buying upgrades or buying buildings, I'm expecting those to cause data to be persisted to your database. And so when I refresh the page, I would expect to be logged out, but I then expect to see that everything that was done prior to me hitting that refresh button is going to show up on the page here. And so the structure for this is kind of like, partially complete. Some of the operations that you're doing don't show up. They're not persisted where they are expected to be persisted, versus it's consistently implemented here. As I said earlier, I do expect you to have that REPL on your page in some obvious way so that the graders can expand it and give you credits if they can see that this data is inserted into the database, even if it doesn't show up visually on the page that you've got. The last two parts are about the security of your database, and these are very much a binary yes, you did it, or no, you didn't do it sort of thing. The first one is about using prepared statements or parameterized queries. So anytime you're dealing with untrusted user input, you're using this idea of parameterized queries to accomplish that. Basically, the grader should not be able to inject SQL into your application. They will try beyond just visually looking to see if you're using the .query method and passing arrays as separate values. But they shouldn't be able to do that at all. And the other thing is about securely storing data here. So again, you either did it or you didn't. You're either storing a hashed password or you're storing a plain text password. Please store hashed passwords. But I've also put in here, and I wrote this, and I'm going to say it out loud. It's weird for me to assess you on not doing something, but I think it's really important to say this. Don't write it yourself. Like, don't actually implement hashing yourself. Use a trusted library. So I'm strongly recommending that you use that Web Crypto API, but ultimately, don't write your own PBKDF2. Don't write any of that stuff by yourself. That's something that you can do in fourth year and probably never again unless you become like a security consultant at some kind of a research institute that's responsible for building this stuff. So for both of these last cases, it's going to be very much, you either did it or you didn't, but both of them are kind of required for what I'm looking for here. All right, so I'm going to go back to my slides here for a minute. Again, I'm going to give you a chance to ask some questions, but I want to pre-clarify some ideas before I give you a chance to ask questions. The first thing I want to do is talk a little bit about this idea of what I mean by inventory classes or inventory tables. I want to emphasize that I'm really expecting you to not have any classes in your domain model that represent all things. So there shouldn't be any kind of concept of all user accounts in your domain model. This is the responsibility of the database. There shouldn't be any concept of all products. This is the responsibility of your database. There shouldn't be any concept of all buildings or upgrades. This is the responsibility of your database. Yeah. So the trainer class instance of a team, this is different from all Pokemon that are available. So I'm gonna talk exactly about this exact example because I just cannot stop talking about Pokemon, but that's what's gonna drive the example that I'm gonna go through here. So I wanna visualize this idea. So I'm gonna pop over here. What I mean ultimately by this idea of an inventory table is that we're still going to have tables that are things like for our instances of trainers. And so for this table, I'm just going to put name here, but you can assume that we would have the rest of the columns for this, and we'll have trainers like Franklin, and we'll have trainers like Walter here. And then ... These are all of the trainers that are in our system right now. So we're still going to have this table that represents an instance of these trainers. We're still going to have a table that represents instances of Pokemon. So to your question, we will still have that concept. We're still going to have domain model classes that have collections of things. But these are the collections of things that are related to that specific instance of that type. So here, with our Pokemon, we're going to have things like nickname and owner. And we'll have Pokemon like Bulby that's owned by Franklin. We'll have Pokemon like Charmy that are owned by Walter. And we'll have Fire Moon that is owned by Kid. There, Kid. Kid is a trainer now, and she has Fire Moon. We still have these concepts. This is a core part of your system. You have to have those kinds of collections. The kind of inventory that I'm thinking of here is something that's more like going to represent a separate table where the separate table is going to represent the list of all Pokemon that are available in the system. These don't represent instances of Pokemon anymore. They will become instances as you get them from the database and populate lists of things so that you can accomplish tasks. But these really represent all of the things of that type that are just available in your system for use elsewhere. So I'm going to draw this table out. This is going to be my Pokemon inventory table in my imaginary database here. I'm going to have columns for things like type, and we don't currently have this on our Pokemon class, but this is where I would be putting things like I want to have a Metapod. I want to have a Caterpie. I want to have a Pikachu. And I want to have a Ponyta. And then ... All of the other 151 kinds of Pokemon, and I'm absolutely going to gatekeep you on Pokemon. There are only and only ever will be 151 kinds of Pokemon, and I refuse to accept anything else. That was gray, I'm sorry. I'm going to use a different color to represent that. Let's choose this so that you can actually read it. Can you read the gray? Should I cover it? Okay, I'll just leave it gray, but I'll write the rest as something else. The other thing that I'd want to have in this is going to be the default properties for these. So things like their initial HP. And I'm going to also add something like their level. And at least for the Pokemon that we've got here, I'm going to say things like Metapod are pretty early game, so they're going to have an initial HP of 5. Caterpie, same thing, kind of early game, 6. Pikachu is a little bit later in the game, so we'll say that they've got initial HP of 20, and Ponyta is very far into the game, so we'll say that the initial HP for a Ponyta is 50. So I'm going to have many of the same properties on this table, or all of the same properties on this table that I would have otherwise had for my actual Pokemon table, keeping in mind that this simplified example is an intentionally simplified example, so I just don't have to draw out the whole thing. But this table will still have initial HP and nickname and owner and the other properties that we've defined for Pokemon. I'm going to fill in some values here for what their level are. So for a Metapod, again, this is very early game, and Caterpie is very early game, but Pikachu is later in the game, and Ponyta is much, much later in the game. So we'll have levels for each of these different Pokemon. And the very last thing I'm going to have in a table like this one for this specific example is going to be the area. So I want you to imagine in your mind theater right now, like you've got your Game Boy in front of you and you can see the whole map. You have acquired the town map from your enemy's sister. I don't know why she gave you the town map, but she gave it to you anyway. And you can see all the different areas that are in the game. And one of the ways that we can find different Pokemon in our game to catch them all is to go to these different areas, because these kinds of Pokemon only actually show up in these different areas. So, for example, our Caterpie and our Metapod are only going to show up in Viridian Forest. So, if this were a more complete example, we would have an areas table. We'd have something that represents the different kinds of areas that a Pokemon can show up in, and these would be foreign keys to that table. Pikachus in the original games, they only show up in Power Plant. And Ponytas show up on the Cinnabar Lab. So this is much, much later in the game. The Pokemon inventory, I'm going to add to this. This is going to have 151 rows for all Pokemon to represent 151 rows, and I'm going to write in parentheses here, all Pokemon. These don't necessarily correspond to instances. This is just the list of Pokemon that you can catch in the game. In our code, then the kind of structure that we're going to use this for, and I'm going to use some pseudocode to describe the operations. But if I were to be in an area of Kanto, I'm going to want to be able to get a kind of random encounter Pokemon from the list of Pokemon that are available to me. So I'd have some code that's kind of like this. I'd say let Pokemon is equal to an array of Pokemon. I am going to have to make instances of the Pokemon that are in that region. And what I'm going to do is I'm going to make this array of Pokemon from a selection. So I'm going to select star from Pokemon inventory. Where their area is equal to $1, I'm going to say for this right now. So I'm in Viridian Forest right now, and I want to get a random encounter. I'm going to select from this inventory list of Pokemon for that specific area. Once I've got that, then I'm going to be able to say something that's like, let opponent equal Pokemon. So from this array of Pokemon that I've got, I want to get some random Pokemon from this list. So we'll just say that all of the Pokemon in the Viridian Forest area are equally likely to show up. I'm going to then go through the battle with this Pokemon, and eventually I'm going to capture it. I'm going to throw my Pokeball at it, and I'm going to capture this specific Pokemon. And so here, I have this concept of the current trainer that's logged in right now, and I'm going to say add to team. Opponent. I'm going to take the instance that I got from this inventory table, and I'm just going to save it as a Pokemon on my team now. That's going to cause some new row to show up here. So let's say that I got a Metapod. No, I want to get a Caterpie so that I can evolve it to a Metapod, but it'll still have Tackle. So I'm going to have a Caterpie. It's going to be populated with a synthetic ID. It's going to have an initial HP, and I'm going to assign it to myself as part of that operation. When I then load my team, I will have an instance of Pokemon that's on my team, and this is now distinct from the thing that's in the inventory table. So I'm going to load instances from this inventory table. I'm going to do stuff with them to get kind of a copy of it. I'm going to load them here. I'm going to do something with it, and then I'm going to save it back to the database. I'm going to add it to a collection that's for a specific thing in my domain model. Are there any questions about that? Does that make sense? Yeah.
So our table for actual Pokemon that exists, can we have a reference to the inventory table from there?
So the question is, ultimately, can we have a reference that goes from here back to this table? So some kind of a foreign key to this one. That would be a reasonable way to represent this, yes. However, I'm going to say that at least with the stuff that we're doing right now, that would kind of stop us from having things like changing costs over time in the store. If a banana costs 10 cents right now and that's part of my inventory, but I want to change the cost of a banana at the store right now to 10 cents, the purchased items or the receipt or the cart table is going to have references to a banana that has 10 cents as a cost, and I don't want to change those things that have happened in the past. So I'm going to say that at least for now, you should just be copying the data to the other table as opposed to having references to the other table. This is going to lead to duplicate information. That's fine. That's totally fine. You can also have like some parts in the inventory table and some parts in other places. If you wanted to deduplicate the idea of a description, for example, so you don't have that description duplicated in all of the rows in your actual instances table here, that would be fine. But again, same sort of thing. If you change the description, that changes the description for everything as opposed to the things that have been bought after that.
So we don't want the already existing objects to be changed?
In this case, I'm going to say we don't want those to change, no.
So it's like, it's going to be the entire copy of Pokemon Inventory just with some additional stuff?
It's going to be the entire copy of Pokemon Inventory, but with some additional stuff. So the Pokemon Inventory table here wouldn't have a concept of nickname or owner because they don't belong to anybody yet. When we insert them into this table, they're going to have the same sort of properties. They may not have Cinnabar or they may not have Viridian Forest because we don't need that information once you are on a team of somebody. But it's going to be the same kind of set of columns that are showing up in both of those tables.
These kinds of tables, I'm not sure if they're actually called like that, but I think I read it somewhere, like it's master tables or master data that is like static and doesn't change.
That's actually not a term I've ever heard before, but that's not because it doesn't exist. It just means I've never heard of it before. Yeah. Any other questions about this? Is this okay so far? Yeah.
So like for me, when I was working on my project, in the view we have like, for example, we have a product, and so we have multiple products that implements this interface. And so to do this in one time, like in the view, I had to make something called like a product catalog, which has all the products and then their constructors there.
Yeah.
So should I remove that?
Yes.
It's similar.
So your idea of a product catalog, this is kind of what I mean by this is a domain model class now that has the idea of everything, of all instances of products. This is where that goes now. So this becomes your catalog. You could call this table a catalog table if you want instead of inventory. But oh my gosh, my words are not coming out today. The concept is the same. To have like, represents all of the things that are available in your shop.
But then like the catalog had the constructors too, so like I didn't have to search for the constructor. Now when we get the name from here, how would we get the constructor? We need to do like if else, if else.
You're going to have something that's going to do the same sort of reverse back from like when you have that discriminator column. If you were to take all of your inheritance hierarchy and smush that down into one table, you have to have that same concept anyway. You still have to do that in either case. Yeah.
I just want to clarify, just to make sure I'm understanding this right. The Pokemon table is responsible for, like, for storing the relationships between a trainer and Pokemon.
That's right.
Instance of Pokemon.
The Pokemon table here represents the connection between the trainer and instances of Pokemon that are on that trainer's team. Yes. Okay.
Sorry, I heard the connection between the trainer and Pokemon in my mind when we watched the anime.
I never watched the anime, not as much. No, I was Dragon Ball Z. That's where I was. Yeah. Anyway, yeah. Can you repeat your question, please? Is it compulsory to have an inventory? You should not have hard-coded English language strings or hard-coded values in your domain model. If you do, and you probably do, this is where that now belongs, is to have this concept of an inventory or a catalog. The cart should still have products. So in this model that I've got here, the actual class trainer, this still has a team that is an array of Pokemon. We still have this relationship between instances of Pokemon and a trainer. That still exists. It's more that we don't have a concept in our domain model of all Pokemon that are available for us to capture. And so that's what we're trying to model here in this table separately is these are all of the Pokemon that are available to capture. These are all the Pokemon that we could add to somebody's team. So in a shop, this would be, these are all the items that are in your store that you can add to a cart. Adding them to the cart then is kind of the same idea as adding a Pokemon to the team here. I'm going to make an instance or copy an instance of a product to the cart for the person that's currently logged in. Well, you'll do that in wherever you're doing that. So like that might be part of your domain model, adding to your cart. If your cart is an instance in your domain model, you'll have a method that adds to the cart. But that's where you'd be doing that sort of operation.
You say you don't want hard-coded strings. How would you want the representation on the site? Before prior to inserting into the database, right? So for instance, types of Pokemon, you're inserting different types of Pokemon, right? And ideally, or usually, the representation of those types would be in the domain models for the Pokemon. So how would you instead insert into the database?
So how are we gonna have these concepts of different things? The insert statements for this inventory table will show up in places like your create_table.sql file now. So rather than having them be in your domain model, because that's where you've got those hard-coded strings and values right now, you're going to have these insert statements. They will have the hard-coded strings and values in them right now. Yeah. Yeah.
So the user should not be able to kind of manipulate those inventory tables. Those are static.
Yeah, the user will not in any way manipulate these tables. The only way that a user will use them is to kind of have access to you giving them a list of this is what I was able to get from the database from this table.
About the interactions with the database, like both the controllers and the model classes can like interact with it without like breaking a single responsibility or anything like that, or it should be exclusively the model classes.
The model classes, so both of them can interact with the database, but through the model classes. So with the code that we've been working with in class, we have methods that are static. The controllers are welcome to call those static methods to get instances of the domain model. It shouldn't have any SQL code in and of itself, though. So your product class might now have a get inventory method on it that runs SQL queries that will load all the different kinds of inventory into your system into an array. but the controller itself shouldn't have any reference to the database.
Will we eventually separate all the methods that interact with the database into a separate layer or something?
You can separate them, I guess, if you want, but as far as we're concerned right now, we're just going to have them bundled together in the same classes. Yeah.
Just, and we're not changing the domain model that we've written out in Mermaid anywhere. We're just going to have the like different. The Blinky Clicker project is still going to have the upgrades represented by an upgraded interface. It's just that this is how they're represented.
This is how the collection of all of them is represented in the database, but that's explicitly not part of your domain model.
Right.
Yeah. These do represent things that will eventually get turned into instances of classes in your domain model, but there's no concept of all things in your domain model at that point. Yeah. Okay. I'm going to give you more time for questions for the project, but I do want to get to the other part of this discussion. So I'll post a copy of something that looks like this up on the course webpage so you have access to this diagram. The other thing that I want to spend some time thinking about now is repeatable test execution and this idea of environment variables. So I would like us all to think back to, gosh, I don't know, 3 months ago, I guess. What was 3 months ago? 3 months ago was January. Yeah, 3 months ago. It was kind of late December, mid-January. At the end of Comp 2452, that's where I want to put us back here. At the end of Comp 2450. I don't know about all of you, but my brain is just not there today. It's just not happening. At the end of Comp 2450, I had written a test harness for you, and I said, here you go. Here's a real bad test harness. And now we're using an actual test framework, and that's great. I'm really happy about that because you no longer have to use my terrible code, and you get really nice outputs from this test harness compared to what I was preparing for you. We're also using an actual real live database. We're using PG Lite, and while it may kind of just be like this feels like a fake database because it's just living in our web browser, this is a legit database. This is something that is used in production in lots of places in the form of PostgreSQL. This is PostgreSQL underneath. We're using an actual database and not just like extremely coarse-grained, reload the entire JSON file every time something is saved. And that's amazing. I am really delighted by that. In the last 7 weeks of classes, we have come very far from where we started at the beginning of this course. I'm going to go over to my terminal here. I'm going to quit out of LazyVim. And I'm going to run npx vtest. And I'm going to run it the way I was demonstrating it to you. And oh no, our tests failed. We haven't actually run our tests since we've done a lot of this stuff. Oh no, the database is breaking our tests. So we've done a lot of cool stuff, but we've kind of like broken things on the way to getting there. And so we need to be able to make some decisions about what the database is doing based on where we're running it. I'm going to go over here, and I'm going to zoom in a little bit on the text here. I'm going to zoom out eventually, but I'm going to zoom in on this for now. All the errors that you see underneath this test failure are related to PG Lite. They're all related to the database. Cannot read properties of null and then reading open. This is an inscrutable error, but I'm going to just tell you what the problem is here. When I'm running npx vtest run here, I'm running in Node. All of my tests are running in Node. When I load this up in my web browser, I'm running everything in my web browser. So all my TypeScript and JavaScript code is running in my web browser. I'm going to zoom out a little bit again. I'm going to run NeoVim. And I'm going to look specifically at this file right here. On line 5, when we're creating this instance of a PG Lite database, we're saying that I want to use indexed.db as a backing storage location for my data. My web browser absolutely has indexed.db. Node does not. Node doesn't have any concept of IndexedDB. That's not a thing that exists in Node. And so what we need to be able to accomplish here is I've got to be able to make a decision about, am I running a test right now? Am I using Node? Or am I running in the web browser right now? Am I loaded up in the web browser and there's somebody clicking on buttons and interacting with the database with me? What I want to do with this, I'm going to open up the PG Lite documentation here. What I want to do with this is I want to be able to create an instance of PG Lite, and I want to be able to create an instance of this not with IDB here, but rather with memory or file. When I'm running with Node, I'm running like on my system in my terminal. And so an in-memory database is going to just store everything in memory, and it's going to be this ephemeral storage that will just go away when the tests are done. Or I want to use file storage. So I want to actually write a file name that represents the backing storage location for the data that I've got here. But I've got to make decisions about which of those two things I'm going to do based on which environment I'm currently running in. So whether I'm running in the web browser or whether I'm running in a test environment. To accomplish that, we're going to use a new concept, a new to us concept that's called environment variables. Really broadly and at a high level, an environment variable is, it's a variable, but it's not provided to us by code that we've written ourselves. I'm not declaring a variable for use in my code, but rather this is a value that I can get from my environment. So the web browser or from Node. This is a value that I can get from my environment that is provided to me by a certain name. So they're still going to be named values, but their location is not going to be in code that I've written myself. There's no let location equals in the structure that I've got here to get access to the environment variable itself. Environment variables can come from a few different places on our systems. One of those is from the operating system or from the environment itself. I've given a link to you here to the Tools and Techniques textbook that describes this idea of environment variables in your shell. I welcome you to look at this in your own time, but this is not something that we're going to be talking about for us. The other place is files that are loaded by the app. If you have ever seen anything like this before, it might be in the form of something that's called a properties file. The other place, and this is kind of the same thing, is these are files that are loaded by the framework. So when I say by the app here, I mean your code has written something to open a file and read it. When I say loaded by the framework, this is the framework itself just has well-known locations that it uses to get environment variables from. And so we're going to take a look at loading environment variables that Vite itself and vtest are going to be able to use based on the environment that we happen to be executing in. So I am going to go back to my code here, and I'm going to make some changes to my code. On the course webpage under today's lecture notes, I've given a link to a specific commit in GitLab that documents the changes I'm going to do here. So you don't have to dig through and find all the changes that I'm making. You can have a reference directly to the changes that we're making to this. The very first thing I want to do is I actually want to fix our tests because they are broken even to begin with. So one of the things that we did was we added to this Pokemon concept that Pokemon must have a trainer, but we didn't change our test to reflect that. So I'm going to make a very minor change here, which is to just reorder these statements. So I'm taking the trainer construction and putting it before the Pokemon. And I'm just going to pass that instance of trainer to the Pokemon that's being constructed here. So this fixes our compile time errors with the tests that we've got. But no other behavior is really expected to need to be changed for our tests themselves. Then what I want to do is I want to start making some files that I'm going to be able to use to control the environment that we're working with. And I want to be able to ask questions about the environment that we're working with. I'm going to start by asking questions about the environment that we're working with. I'm going to do this in the connection file itself. So the connection file is the one that's responsible for creating the connection or creating the reference to the database that we're using. And so this is the place where I want to ask those questions about our environment. So to start, what I'm going to do is this. I want to ask questions about the environment to decide where to put or store our database. So in memory versus IndexedDB. I'm able to ask questions about my environment using a special variable that I have access to. And the special variable that I have access to, I'm going to say this, let source is equal to, and the special variable access is import.meta.env. So this is now going to give me access to the environment variables that are available to my app to use. And then accessing specific environment variables then is going to be a dot after this. And the one that I'm going to use here is called Vite database URL. The prefix is important. So the Vite prefix is important. You can name it whatever you want after that. So everything after the Vite underscore, you can call it database, you can call it DB URL, you can call it anything that you want, but Vite itself will only give you access to environment variables that have this Vite underscore prefix. This is loaded by our framework, so this is a rule that we kind of have to abide by in terms of that. Whoops. Come on. You can kind of have anything that you want after the Vite underscore prefix here. Once I've got this source, I'm going to change this now to not load directly from that, but I'm going to say that I want it to load from the variable that I've loaded from my environment. So I'm going to say I want you to create an instance of this database that's using this value that I have loaded from my environment variables. And then we're going to have to add environment variable values to two places. One is going to be, I need to have this one value set when I'm running a test, and the other one is going to have to be set when I'm loading my application for the purposes of using it in my database. To create the one that is going to be used in our database, I'm going to add a new file. This is going to be to the root of my project directory itself. And the file is going to be called .env. So the first character is a dot, and then it's env. It stands for environment here. When I create this, at least on my system, it doesn't show up here. The dot prefix is a special name on Unix and Linux systems, so Mac OS and Linux, that effectively means this is a hidden file. This is not something that will show up when you're listing the contents of directories. This might show up on a Windows system. This might show up in WebStorm. This might show up in VS Code. So I have to be really honest. I don't know how to open this file with NeoVim, so I'm going to have to leave NeoVim so that I can open and edit this file. So forgive me for that. I'm going to open up a new terminal here, and I'm going to change to this same directory that we're in right now. And if I do lsal here, we can see that I've got this .env file. I'm going to edit this .env file. And what I'm going to put in this .env file is that string. So in my connection file, connection.ts, I've got Vite database URL. This is the same name of the variable that I want to put here. So Vite database URL. And I'm going to say that for the web, this is my IndexedDB thing. So .env represents my web. I'm going to say idb://2452 imon. This is the name of the database that I want to have for this project for the web. The web database should use IndexedDB. The other place that I need to make a change to is going to be in my test configuration. So that's going to take me to this vtestconfig.ts file. And what I want to add to this is below coverage, I'm going to add env. Anything that's in here will replace what's in that .env file. So it's going to replace all of the variables that we load from that. And I want to say pretty much the same thing here, vt database URL. But this time what I want to say is I want this to be a memory database. So I don't want you to try and use IndexedDB for this. I want you to use the memory database. So now when I load npx vt on my command line, it's going to use that .env file, and it will put idb:2452 imon into database URL there. And when I run npx vtest, it's going to use this vtest config to figure out what that value is. It will replace vt database URL with memory://. We don't have to put anything after the // in memory here because we're just loading it into memory. It's just going to kind of keep this ephemeral storage that will just get thrown away once the app is done. I'm going to save this. And then the very last thing I'm going to do to this is this is going to be a little bit of a hack on my part. I welcome you to do this better, and I might change this later, but one of the problems that we've got right now with this, so if I go to my other terminal here where I've got my env, if I run npx vt, this will start up. If I load this in my web browser right now, this does actually get data from the database. It's been configured with the database URL that is that idb1. If I run npx vtest here, it's going to start to work, but now our problem is that the relation trainer does not exist. Relation here means table. The table trainer does not exist. That's because we did our DDL loading in main.ts. And when I'm running vtest here, it's not running main.ts at all. And so I'm going to add one last part to this, which is I'm going to ask this question, if source is equal to memory, I'm going to do the same thing that we have in main.ts. So I'm going to get a reference to db here, which is just in the file that we're looking at, .exec, and I'm going to write DDL. And just above this, just like what I had done before, I'm going to import DDL from createtables.sql $raw. So this will load that DDL as a string, and then it will execute it when we start trying to load up our memory database. So this will cause that DDL to get executed just before we start to do anything with the test suite. So I'm going to save that. I'm going to pop over to my other terminal here, and I'm going to run npx vtest run, and now our tests are working again. So we've got this actual database connection that's sitting in the background, and it's using the using the database in memory as opposed to trying to use the IndexedDB. If I go back and run my, my web browser here again, and I refresh this page, we're still loading stuff from IndexedDB here separately. So we're now making decisions about the two different environments that we've got here. All right, so I will push up this code for you after class, but like I said, I've given a link directly to the commit that I made that has exactly these changes in it, so you can have a clear idea of what I've done to the application. Yeah, at this point, I'm going to let you ask some questions about the project. So I'll take verbal questions first, but I'll keep this up on the page.
Do we need to create additional tests for our database, or that's enough that we have right now?
So the question is, do we need to create additional tests for our database? The database is going to get tested as a part of testing your domain model classes. And that's, for us, that's good enough. We don't need to explicitly have tests that are going to evaluate the behavior of database functions. You're welcome to if you want, but as far as I'm concerned, we're getting that testing done by testing our domain model instances. Yeah. Well, so the question is, are we expecting your app to show the contents of the inventory? You kind of already are showing the contents of the inventory in terms of being able to view the products on your system. They're showing up on a page somewhere. The difference now really ought to be that your view ought to be just looping over the values that have been provided to it that represent all the products that you've got in your system. I'm going to go over here, but I will take questions. Yeah, from the audience here first.
Scaling, upgrades, and building SaaS provider. So for example, I buy a building with 50 clicks, the next version of that building I buy should be 75 clicks.
So that's a fair question. The question is about cookie clicker here. Those grandmothers are really terrifying now. The question is really, cursors, when we started this game, I think they cost 15 clicks. Like the first one cost 15, but now they're cost 3.866 trillion clicks because we're trying to buy our 189th clicker, our cursor. My answer to this is no, you don't have to. That would make the game more fun, I guess, but it's not something that I'm asking you to do. You could accomplish this ultimately by, in the sort of the same way that I'm strongly recommending that you calculate the clicking power, just iterating over the list and figuring out what your clicking power is. You can also iterate over the list and ask if the cost of this thing will go up based on what's currently in the list. But the short answer is no, you don't have to do that. It would make it more fun, but no. Yeah.
So you mentioned the mocking thing that we can also do. That mocking thing is an alternative to whatever we have done here right now?
Yes, the mocking thing is an alternative to what we've done here today. So if you're going to pursue mocking, you're welcome to do that. I'm going to go off of cookie clicker here. I'm going to burst all of our wrinklers here, and then I will go back to the... Oh, and then I'll buy this upgrade, Arcane Sugar. And I'm going to upgrade our grandmas. Okay, I'm going to go back to Mentimeter here. Mocking. Yeah, mocking is about doing the same thing that we've done here. So you wouldn't have to do all this stuff if you were going to use mocking to accomplish this task. I will again say, please don't let that get in your way, though. Don't let that get in your way of success when this works. This is a functional way to accomplish that task. Yeah. Yep. The password that's stored in the model. What do you mean by that? Like, as it enters your model, should you encrypt it? Or should you hash it? I want to make sure I'm being careful about those words. Yeah. Encryption actually means something different than hashing, but that's kind of up to you to decide. It doesn't really make sense to me to have the value of your password be plain text in your domain model even. It doesn't really make sense to me to do that if you're only ever going to store it as a hashed value, and then you'll only ever compare to it as a hashed value. So hashing it effectively as it enters your domain model, like in your constructor or as a mutator, never having it in plain text seems to make sense to me. Yeah.
For the cookie clicker project, it mentioned specifically that you have to make a new type of upgrade that like refreshes on an interval or adds on an interval to this. I think it also mentions that you have to have exactly two of those.
Two kinds of them.
Kinds of them.
Yeah.
Yes, sorry. Do those exist alongside the upgrade to make stage 1? Or do they?
Yeah. So kind of like cookie clicker here.
Yeah.
We've got, these are the upgrades that are available to us, and these are the buildings that are available to us. So I'm looking for two different kinds here and two different kinds here. When I look at the stats, like these are the upgrades that I bought. These are the ones that are still available for me to buy. The buildings, they never really go away from this view because they're always available for me to buy. Yeah. Will phase 3 be larger than phase 2? Phase 3 is going to be looking at different stuff. So I think I said this last time, like the stuff that was in phase 2 kind of ends there. Well, I guess I'll say now it actually ends today, but because I've added some minor new things to you. In phase 3, we're going to be really looking at the idea of human-computer interaction and user interface design. And I do want to spend a little bit of time building in some kind of basic AI stuff. But the concepts that we're building into this aren't necessarily going to be increasing substantially, no. It's going to be more about refinement of the existing stuff that we've got. Does every domain model instance have to have an ID? It has to have a key, almost certainly yes. But it doesn't necessarily have to have an ID. When I'm using the word ID, to me that means it's a synthetic key, but many of your classes can and will have natural keys. So the one in my mind that sticks out immediately as one that has a natural key is your account concept. The username really ought to be a natural key on that class. And thus, you don't need a synthetic key on that. You don't need to have an ID field for your user account idea. All right, okay, awesome. Then with that, I think we will click a couple of more cookies here. I'm thinking that I started the Gram Apocalypse without you. And so I think that next week we may ascend in this section. And that's a whole different minigame. When I said that cookie clicker was superficial at the beginning, I really meant it. We'll ascend next week. I will promise you that. We will ascend next week in this section. Let's switch topics entirely. For this part of the course, we're really not going to be thinking that much about code. We're really not going to be thinking that much about Pokemon, but instead we're going to start thinking about Adventure Time. I want to spend some time thinking about human-computer interaction. And the start of this really is just giving you a definition of the overall idea. We've got 5 minutes left, so we're not going to get too much into this today. But I want to start with a definition of what this idea is. I think a lot of people are exposed early. I'm going to just leave this on this so long so that you can see BMO, poor BMO, just getting hit over and over and over again here. I think a lot of you have been exposed to this idea of UI/UX before. I think that a lot of you have seen this. It's okay if you haven't, but I want to make sure that we understand that what we're going to be talking about in this course does not necessarily reflect something that makes a great looking UI. What we're going to be thinking about in this course is something that makes a usable UI. That is what we are focusing on. So I'm still not going to teach you CSS as part of this course. Our user interfaces will still look like absolute garbage. But again, to be giving you all credit, many of you have made excellent looking UIs. I'm going to have a garbage looking UI, and I don't really care, but I'm going to make it a usable UI. Human-computer interaction is a domain in computer science, is a discipline within computer science that's really about the study of how people interact with computers. That's really the high-level idea here, is that we want to spend some time like making observations about how a person actually sitting in front of a machine will interact with the software that's on that machine. This does involve designing new ways of interacting with computers and machines. We don't want to just sit back and watch somebody do something and figure out what needs work and what doesn't need work. We do actually want to like make changes and come up with new ways that people can interact with systems, and then make observations about that. Has this kind of interaction that we've done made it better for this person that's trying to interact with this system? In Comp 2452, we're not going to be doing design that will yield new kinds of user interfaces, and it's not going to yield any new kinds of interactions with interfaces. The goal that we have in Comp 2452 is that we want to take a look at existing user interfaces, so either ones that are out in the wild, or for you, it will be assessing your own user interfaces, the ones that you've been preparing as part of your projects. And we want to make assessments really about whether or not these interfaces satisfy certain heuristics that are informed by standard design principles. This topic that we're going to spend some time on in this course will lead eventually to Comp 3020. This is Human-Computer Interaction 1 and Comp 4020. This is Human-Computer Interaction 2. In Comp 3020 and Comp 4020, you will talk about these ideas of standard design principles. We're kind of doing like first steps of what eventually leads to design principles, but we're not talking about design principles. And so we're using the word heuristic to describe this idea. Heuristics for us are tools that we're going to use to assess the quality of a user interface. The ones that we're going to be thinking about in this course are visibility, feedback, and consistency. These are the three heuristics that we're going to be using to assess the user interfaces that we've got in our systems. Some of these, as we step through them, to us, and keeping in mind who we all are going to appear to be obvious. Of course we should do it that way, or of course I would do it that way. We're going to be looking at existing user interfaces that I want to be clear are real software that have been made by real people and are used by actual real people. I don't want to throw anyone under the bus. I'm not going to say that any of these are trivial things. Some of them are going to appear to be obvious from the outset. Of course, I would do it that way. Of course, I'm going to think about it this way. But our goals really are to share and formalize common ideas about what these heuristics are. So how are we together going to be assessing these interfaces? I want to make sure that we all have the same idea of what the assessment is. And I want to make sure that we all have the same idea of what it is that we're trying to accomplish. But the really big goal that we have for this is that I want us to start thinking about the people that are actually using our software. This goes back to Comp 2450 now. In Comp 2450, we were saying, when you put error messages on the screen, they must clearly say what the problem is and also say how to fix the problem. So what is the expected input that I'm trying to get from you so that you can give me a valid input? This is an extension of that, and we're going to try to formalize some of these ideas. I want us to start thinking about how people are actually using our software and the kinds of people that are actually using our software. I'm going to give you this, and then we will come back to this next week. But our first heuristic is this heuristic that's called visibility. The big idea behind this is that users really only know what they can do in an application based on what they can see, what is visible on the screen right now. I shouldn't have to make guesses about what I can do by looking at the screen in the application that I'm working on right now. And so this involves a couple of different questions. The questions here are possible actions at any given time or context visible or easy to make visible. So the things that I can do in this application, is it straightforward for me to see this at any given time? If there are actions that are possible sometimes, so if I have the ability to do this in certain circumstances, is it visible but disabled to inform the person that's using my software that they can do this action, but just not right now? And if I'm given information on the screen and just the screen, do I know where I'm at? Do I know where I'm at in terms of the process or the flow of the application, what I'm able to do, and kind of what I'm doing at this point? We're going to come back to this next week, but at this point, you should know a lot more about the phase 2 implementation expectations, and you should continue to be able to use a testing framework to automate running test suites. We have accomplished beginning, assess them using heuristics informed by standard design principles, but like I said, we will continue taking a look at this next week. That's it for today. Thank you all for coming out. Thank you all for an extra minute of your time, and I hope you have a great